welcome to Intermediate Data Visualization in Python. So we're going to be mainly building off of the intro to data visualization, but it's not going to be too complex. You know, I said intermediate, but a lot of the things that we're going to be covering are just mainly the same plots or more in another package. So we're just going to be saying unique ways of visualizing data, nothing really too complex here. And then we're just going to talk about the package we're going to be working with, and then introducing the data set and then coding. So for today, we're going to be using Seaborn, which is another type of data visualization package in Python. Last week, or the intro to data visualization, we used Matplotlib and pandas. And while those are good, and those are things which are also really popular, Seaborn provides a wide variety of plots that we may not get in Matplotlib. And there's just easier syntax and more customization and just unique ways of visualizing data. So yeah, we're going to be going through that today. And with that, let's go ahead and get started. I'll send the link here. It's a loan prediction data set. And then the collab notebook. And so go ahead and do the usual, download the data set and get into the collab notebook, and then yeah, tell me when you're ready. And then make sure when you get to the collab notebook, you go up here. I have instructions here as well. This is a view only, so you need to make sure you save a personal copy of this notebook. So you're going to go up to the top here and go File and Save a Copy in Drive. And that will allow you to work alongside me. So take a few moments and do that. And, all right, so as usual, we're going to be importing packages. So today we're going to be using pandas, Seaborn, and Matplotlib. So we're going to be installing 3 packages today. So let's go ahead and do that. So import pandas and the alias name as PD. And then we're going to import Seaborn. So actually I'll do Matplotlib first, since we know how to do that. So remember, we want to get the pyplot package from Matplotlib. So we're going to do import Matplotlib pyplot as PLT. There's an autocomplete. And then with Seaborn, the alias name that we use for that is called SNS. That's just a standard practice. You can use whatever you want, but generally most people use SNS. So we're going to do import Seaborn as SNS, right? So these are 3 packages we're going to work with. And you may be wondering, why are we using Matplotlib? Obviously, you use pandas to load in the data frame, right? But you may ask, why are we using Matplotlib if we're using Seaborn? That's because Matplotlib also allows us to set axis titles and like plot titles and things like that. So a lot of times, even though people use Seaborn, you'll oftentimes be combining Matplotlib and Seaborn, because Matplotlib allows you to add those axis titles, and then Seaborn, you can actually make your plots. So they're 2 good packages to use together for data visualization. So go ahead and run this code, and then choose the file. So I had renamed mine because it was kind of, when you downloaded it, it was it wasn't very interpretable. So mine is called loan.csv. So just go locate that file and open it. And so once you see it's loaded, go here and to the file icon, and you'll see that the loan CSV is here. And so now we want to load in the data frame. So let's go, let's set that object. So let's call it df equals pd.read CSV. And then we want to get the file path, right? So let's go up here, and these 3 dots next to the CSV, like usual, you're just going to right click and click copy path. And then you're going to go and specify as a string here and Command V, or paste it, Control V. And you have your data frame loaded in, right? So now that we have loaded in the data set, let's go ahead and do some initial exploratory analysis. So let's get the head of the data, right, just to see the first few observations. And we can see that the various columns that we're working with, so this is all a status of, like, this is how they evaluate, whether you're qualified for a loan or not, right? So they look at your marital status, the dependents, what your education is, credit history, property area, things like that. I'm sure it's a lot more complex than this, but this is just the gist of and the context of the data we're working with. So let's retrieve the shape of the data. So we can see we have the 13 columns and 614 samples. So now let's go ahead and get started. So we're going to first be reviewing some of the basic plots from Matplotlib. So like bar plots and count plots are two ways we can visualize the frequencies of the categorical columns. And the reason why I want to show it to you in Seaborn is because it's a lot easier to do these kinds of plots in Seaborn than it was in Matplotlib. If you remembered, we had to do this like complex pandas operations where we wanted to get the unique observations and the value underscore counts. And, this just makes it easier to do in Seaborn. And so to make a bar plot in Seaborn, so what we're going to be doing here is we're going to need a categorical column because we're going to be comparing across different categories. But then we need a numerical column for the Y because we want to compare a quantity across various categories, right? And as always, best practice when you're making any sort of visualizations, you want to set your figure size. So remember that's plt.figure, and then you pass the fig size and the width and height, right? And then we add a title with plt.title. And then to actually make your bar plot, you pass in your data as the first argument. Oh yeah, thanks, Philip. I forgot to do that. Is this better? It should be more zoomed in. But yeah, so you pass in the data, right, as the first argument, and then X as your numerical column and Y as your categorical column if you want a little bit more. Okay. Let's do, right. So you want to make sure that you pass in a categorical column and a numerical column. So if you do it normally, it'll just be across the x-axis, and then along the y-axis it'll be numerical. But if you want to make a horizontal bar plot, then you just flip the axis. So you would just put your x-axis to be numerical and then your y-axis to be categorical, right? And so that's the basic arguments to just put stuff on your graph. But let's say you wanted to plot against a third categorical variable. So you wanted to compare, two different categories across the one numerical. So there's an argument here called hue. I don't know what it stands for, but basically you just pass in this argument and you specify another category, and it will essentially plot two variables against the one. So let's go ahead and just try this out here. So plot a bar plot of the loan amount across the gender categories. So I'm just going to get the data frame here so it's easy to retrieve the columns that we want to work with. So the loan amount across the gender categories. So let's go ahead and let's do that. So let's set the figure size. So a figure, and then the fig size is equal to, let's just do 12 and 6. And then let's do sns.barplot and set the data argument to the data frame object. We're going to be comparing across gender, and then the y will be the loan amount column here, right? So loan amount. Then let's set a title. Let's do plt.title, and let's say loan amount across gender, right? And so you'll see here with 3 lines of code, it was very easy to do so, right? So you got our bar plot here. We even got these confidence interval bars that Seaborn also provides when we plot bar plots. So You can see this is a nice plot here, but we can do a little bit more. But let me first show you how to do a horizontal bar plot. So it's the same thing, just flip the axis. So we're going to have our gender on our Y and then our loan amount on our X. So same thing, let's do plt.figure and then figure size. And let's go 10.5 this time. Oh, I did 50. 10.5, and then let's reverse the axis. So bar plot, data is df, x is loan amount, and then y is gender. And then let's set the title to loan amount across gender, right? And now we can see that we got the same plot, but just on a different axis. So sometimes you may want to plot a horizontal bar plot if you have a lot of columns you're working with, or a lot of categories you're working with. So that's how to do a simple bar plot, but let's make use of this hue argument, right? So let's plot a bar plot of the loan amount versus the gender, same as usual. But let's specify that hue argument with the marital status. So in that case, that column is married. So let's set the figure size. Again, fig size to 12.6. And then let's do sns.barplot. Data is equal to df. Let's go gender on the horizontal axis, and then the loan amount. And then let's go, now we're going to be including a third variable and the second categorical variable. So we're going to do married, right? So that's the marital status. And let's go ahead and make a title. Let's go loan amount across gender and marital status. Let's see how this looks. So here, now we get a side-by-side plot, right? So, this was informative. We got to see overall who had the more loan amount. But with this, we can compare across, okay, depending on male and females, how does it differ versus the marital status, right? And we can look at this and make some insights. And overall, this hue argument helps us gain more novel and more important information that we wouldn't have gotten from just a basic bar plot, right? So generally, whenever I use Seaborn, I always make use of this argument, especially when we have a lot of categorical variables, because, just simple like one categories are not too informative. You usually want to go a bit deeper. So let's keep practicing. Let's plot a bar plot, the loan amount that varies across the education levels. So that's one category, or one sort of like categorical variable, and then the hue of property area. So let's do the same thing. So plt.figure fig size, and let's go 12.6, and then let's plot the loan amount. So that's going to be sns.barplot, and data is equal to df, and x is the education, right? So that column is called education. If you just double check. Yeah, it's called education. And then the y is the loan amount, and hue is education or property area. So we're going to be comparing across another categorical variable, a property area. And then let's go plt.title loan amount across education and property area, right? And so here we get our various, we can compare with how the loan amount compares across the education levels, right? And so, it makes sense why for graduates, right, their loan amount is going to be higher because you go to college, they're going to be paying student loans, right? Versus not graduating, you're not going to college, or you didn't pay your loans completely. So this makes sense. And then you can also compare across the various property areas as well, right? So let's do one more. Let's plot a bar plot the education versus applicant income, and then categorized by the self-employed. So that's going to be our hue column. So let's go plt.figure, big size, let's go 12.6, and let's plot the education across. So let's go sns.barplot, data is df, x is education, y is applicant. Let's go see if I spell it right. Applicant income, so it's one word like this, applicant income. And the hue is self-employed. And then let's set a title. Applicant income across education and employment status. Right. And then we can see here, we can compare this bar plot, right? So that's bar plots. And now we're going to talk about count plots. So the difference between the two is that in bar plots, we were trying to compare some quantity across a category, right? So we had an X and Y. But for a count plot, what we're doing is we're just trying to see the frequency of observations for a specific category. So in this case, we only have to say what our X or Y column is, right? If we wanted to do horizontal. So essentially what we're doing is, let's say we were doing a count plot for the gender, right? So we plot our X column to be gender. We just want to see, all right, how many male or female samples are in our data, right? So that's mainly what we're trying to look at here. It's similar to that value underscore counts argument from, or a function from pandas, where we want to just see the counts of the various frequencies of the column. That's what we're doing with count plot essentially. So you don't really need to specify two axis arguments here. But this hue argument is the same, where if we want to compare across another categorical column, we can do so. Right, so it's just sns.countplot, data, the column, and then hue, if you wish. So let's plot a count plot to visualize the frequency of gender with the hue as married. So we're going to be looking at the genders across the marital status. So let's do plt.figure, fig size, and let's go 12.6. Let's plot a count plot of the data, and let's go X is equal to a gender. So we're going to do that. And then hue is married, right? And then let's set a title to be frequency of genders across marital status. Right. And so now we can see here that we can compare this and see, okay, so the overall frequency of, males and females in our data set, and then across the genders, or across the marital status, right? So we can see that there are more males who are married versus, in this case, females are who are not married. So we can see a difference between the makeup of the male and female counts across this marital status column. And this is what the goal is essentially. We wouldn't have been able to see this pattern if we hadn't incorporated that hue argument. Right, so let's do it again. Let's plot a horizontal. So I'm going to be showing you the horizontal way. So we're going to plot the same exact graph, but I'm going to be specifying the gender argument on the y-axis. So let's go plt.figure, fig size 12.6, and then sns.countplot, data is equal to df, x is equal, or no, y in this case, right? y is equal to gender with hue as married. And let's set the title to gender frequency cross marital status. Right, so this same plot, right, it's just on the y-axis this time. So I just want to prove to you that you can also make horizontal bar plots like this, or count plots. So we see the same trend here, right? Let's do it again. Let's plot a count plot to show the frequency of dependence categorized by the marital status again. So let's set the figure size, right? Fig size is equal to 12.6. And then let's do sns.countPlot. Data is df. X is equal to the dependence. And hue is married. And then let's set a title. Frequency of dependence over marital status. And right, so here in our data set, we either have samples with 0 dependence, 1, 2, or 3 plus, right? So it seems like there's a high amount of samples with no dependence, and we can see that it varies across from whether they're married or not, right? And generally, if you're married, you're gonna have more dependence versus if you're not. So this makes sense. So let's keep going. Let's plot a count plot of the frequency of education degrees with the hue of property area, right? So we're going to be comparing the education status over the property area. So let's go plt.figure, fig size 12.6, and then count plot again, but this time we're going to say education as the main column with hue of property area. And then let's set the plot title as education across property area. Right. And so now we see that pattern here. And obviously, if you're graduated, you're going to have more, the count's higher in this case. So it seems like there's less of samples overall of people who have not graduated. So that's count plots, and bar plots and count plots are the main two functions you want to use when you do Seaborn, and they're very helpful in visualizing those categorical counts. So let's now talk about visualizing numerical relationships at Seaborn. So usually when you visualize your numerical columns, you can look at the relationship between the two with the scatter plot, right? We talked about this in the intro to data visualization as well with Matplotlib. But the thing is, we have more options and more customization with how we can visualize these relationships in Seaborn. So we're going to be talking about three main graphs in Seaborn. And so there's scatter plot, the normal, reg plots, and LM plots are the three main ones. And so to plot a scatter plot, basic, it's just same as always. You go sns.scatterplot, right? Pretty self-explanatory. And then pass the data. In this case, you're looking at a relationship between two numerical variables, right? So we need an X and Y here. And then you can, as always, pass a hue of categorical column. So that's going to split your points on your scatter plot by color. So let's plot a scatter plot of applicant income versus loan amount. And you might notice that for the rest of these, it's applicant income versus loan amount. That's because those are the only numerical variables in the data set. We have mostly categorical variables. So all of these are going to be with applicant income versus loan amount. So yeah. Let's set the figure size, and let's go fig size 12.6, and then let's go sns.scatterplot, and then data is equal to df, x is equal to applicant, income, I think that's one word, and then loan amount. categorized by education. And then set the title to do applicant income versus the loan amount, right? Let's see if this throws an error. Okay, so as we can see here now, we can visualize a scatter plot here. There seems to be a cluster of the applicant income here versus the loan amount, right? And we can look at this with the hue argument, how many of them are educated versus not. And obviously we have more people in our data set who have graduated, so that's why there's a lot more blue. And yeah, with this, you can really visualize your entire data set. But later on, we're going to be talking about how we can split this and only look at subsets. So let's do one more. Let's plot the relationship between applicant income and loan amount, but categorized by the hue of property area. So let's go figure, plt.figure, fig size, let's go 12.6. I'm just doing 12.6, but you can do anything. SNS dot scatter plot, again, pass in your data frame with applicant income and loan amount, and then property area as the categorical variable. So that hue argument will always take a categorical variable. Like you can't pass a numerical one, you can, but what's going to happen is your collab is probably going to crash, because then what it's doing is it's trying to, like, say I did hue of applicant income, it's going to try and like do 6,000 of those, and like it won't do that, right? So make sure you always pass in a categorical variable for hue. And then let's do plt.title, applicant income versus loan amount across property area. And so here we see same relationship, but we can see how it differs across the various different properties, right? So this is something worth exploring. So that's the scatter plot, right? But what if we want to, this is good. We can see like a general trend of how our data looks, but what if we want to plot a regression line, right? We always, whenever we do linear regression, we want to plot a regression line to see that relationship and quantify how strong it is with that line. So we can do this in Seaborn with this sns.regplot. And what this does is it takes your data, your X and your Y. But the thing about regplot is there's no hue argument. And that's because regplot by default is going to visualize that relationship across your entire data set, right? So it's not going to allow you to categorize by certain categorical columns. So when you use a regplot, it's generally only going to be looking at that relationship over all of your observations. But let's say you wanted to categorize by other columns, right? And that's what we want to do. We want to use that hue argument. So what you can do is you can use this sns.lm plot, and the lm plot allows you to not only plot against a categorical column with hue, but you can compare from up to like 3 categorical columns, because along with hue, you also have the column and row. So what this is going to do is, let's say you specify a hue argument, right? And then your column and row, you can essentially compare that relationship across a column of categorical variables and rows of categorical variables. And it'll make sense when I show you, but that's the thing about LM plot, which I like a lot. So I'm going to show you both. We're going to look at reg plot first. So plot a reg plot to visualize the relationship between applicant income and loan amount, right? So plt.figure, fig size 12.6. And then let's do a reg plot, plt.regplot. Oh no, not plt, SNS, reg plot. Data is equal to df, x is equal to applicant income, and y is equal to loan amount. And again, there's no hue argument here, right? And then let's set a title. So plt.title, let's just do applicant income versus loan amount. So when we plot this, we can see here that reg plot will not only just show us that relationship with the points, but it will also plot a regression line for us, right? So we can see that there's a pretty strong relationship between the two. So this is interesting, but we want to always explore a little bit deeper across our categorical columns. So let's do the same thing, but let's categorize by the hue of property area, and let's do that with LM plot. So let's do plt.figure size or figure, and then set the figure size to 12.6, and then let's do sns.lmplot, lmplot, and pass in our data frame. X is the applicant income, and then Y is equal to loan amount. And then our hue will be property area, right? Property area. And then make sure you also title your plot. So when we plot this now, we can see that it doesn't look the best, but with these regression lines, you can kind of look at which is stronger, right? So just from the plot alone, without these regression lines, we wouldn't really see that trend. But we're able to extrapolate more from it with these regression lines, and that's what LM plot does for us. It plots these regression lines, and we can compare it across the various different categories. So let's go a bit deeper, and let's try and use that column or row argument in addition to hue. So plot the LM plot for relationship between applicant income and loan amount. Set hue to education and the column argument to married. So what this is going to do is that it's going to not only split up the points across the education, but our columns are going to be in like a grid, and it's going to be conditioned by the marital status. So let's go plt.figure, fig size, and 12.6. And then let's go sns.lmplot. Data is equal to df, x is equal to applicant income this time, and y is equal to loan amount. And then let's set hue to education. And then let's set column equal to married. And then let's set a plot title, applicant income versus loan amount across education and marital status. It's a long one. What happened? Oh, I didn't do an equal sign here. So make sure it's hue equals the column. And so now we can see that we just plotted, our LM plot, but we have two plots here. And that's because we have specified the married equals no, and then this is married equals yes. I don't know why this is blocking this. Let me see if I remove this title, what happens. Maybe it's blocking that. Usually when you set a graph title, it will block it. Let's see what's going on here. Well, let me rerun this. Oh, okay. Well, I don't know why it's slowing down. Okay. I don't know why that happened. But so now here we can see that we have plotted the applicant income against loan amount like usual. And then we have faceted by the education column so we can see our different color of points. But we also went against another categorical variable with the marital status. So with married equals no and married equals yes. And that's the power of LM plot, is that you can go and specify your columns, more columns than just one. And so let's go one step further. And this time we're going to plot an LM plot for the relationship between applicant income and loan amount with the hue of education, columns with the marital status, and then this time we're going to specify the rows to be gender. Right, so we're going to be working with 3 categorical variables now in order to visualize this relationship between loan amount and applicant income. So let's go plt.figure size, fig size 12.6, and let's do sns.lmplot. Data is equal to df, x is equal to applicant income, y is equal to loan amount, and then hue will be education. The column argument will be marital status, so married. And then for row, it will be gender, right? And then let's not set the X title because it just ends up blocking it. So it takes some time here. So now we can see that we have 4 plots now. So you can see how much more we can learn from our relationship between our numerical variables when we categorize or facet it by other categorical variables. So not only have we split up against the graduate versus non-graduate, but we can see how it varies based on gender, right, in our column. So gender male, or in our rows, sorry, male and female, right? So in gender, but also in marital status. So across the columns, we have married equals no, married equals no, married equals yes, and marital status is yes. So that's what LM plot is used for. I use that a lot because it's helpful for visualizing those extra relationships that you won't really get from just a basic scatter plot. So that's for looking at scatter plots and numerical relationships like that. But another thing we also want to do is look at your distributions, right? We want to look at we would do this with histograms in Matplotlib, right? But Seaborn allows us to go farther than just histograms, right? We can look at 3 other ones that I like to use. That's joint plots, KDE or kernel density estimation plots, and then Violin Plots. All of these basically do the same thing as box plots and histograms, but they're just more fancier and native to Seaborn. So what a joint plot will do is allows us to view a like a conditional distribution of 2 numerical variables. So if you've heard of joint distributions, right? A joint plot initially it essentially allows us to visualize that via two histograms. So the arguments for that is data, your x, your first numerical column, your second numerical column, and then the hue if you want, and then the kind of graph. So you can do joint plots across a histogram, or you can do it across a scatter plot. So you can specify what kind of graph that is. So by default, if you don't specify it, it's going to be a scatter plot. So that's just the default argument. But you'll see that we're going to be customizing that later on. So let's plot a joint plot of the applicant income and loan amount and categorize by the property area. So let's do PLTF figure, and then fig size is equal to 12.6. And then let's plot the applicant income versus loan amount with hue as property area. So SNS dot joint plot. So data is equal to df, x is equal to applicant income, and then y is equal to loan amount, and hue is equal to property area. Right. So by default, like I said, it's a scatter plot, so we didn't have to say kind. So you can see this is pretty interesting, right? This is definitely more than what Matplotlib gives us. We can visualize how the different distributions, or this joint density distribution that's very common in statistics, is shown on a graph for us to see, right? So we can look at it here as the distribution of the applicant income across property area, and then the loan amount here. And it's a nice way that Seaborn allows us to do this with the joint plot. And let's do more. So let's plot a joint plot of the applicant income and loan amount categorized by gender. But this time we're going to specify the kind of plot to be a histogram. So let's do PLTF figure, fig size is equal to 12.6. And then let's plot the applicant income versus loan amount. So SNS dot joint plot, X is equal to, oh no, data, right? Always specify your data first. X is equal to applicant income. And then Y is equal to your loan amount. Hue will be gender. And then the kind of plot this time we want is hist. So I believe that's just histogram. I might be mistaken, might just be hist. Let's just see, let's try hist only. Okay, so when you specify histogram, you just want to say hist for the kind. So here we can see that we have the same exact, gender. This time we're fasting over the gender, but we can see that we can visualize the histograms for the distribution of applicant income and loan amount as that joint density distribution, right? So let's do one more. Let's plot a joint plot of the applicant income versus loan amount, but specify the kind of plot to be KDE. So this time we're not going to do the hue. So we're just going to do plt.figure. Fig size is 12.6. And then SNS.joint plot as data is equal to df, x is equal to loan amount, applicant income, and then the kind of plot to be KDE, so kernel density plot. And so here we get another type of joint plot, but just with the KDE. So this just shows how those points are aggregated together and that relationship and their overall density. So where a lot of the points aggregate. So when they're closer together, those lines, that means there's the density, or there's a lot of points for each which fall within this range. So that's what the kernel density plot allows us to do. It allows us to see where a lot of the points or observations in our distribution lie. So let's do one more. Let's plot a joint plot of the applicant income versus loan amount term and specify the kind of plot to be KDE, right? So let's do plt.figure, fig size 12.6. And then let's plot the joint plot again, SNS.joint plot with x, or data is equal to df, x is equal to applicant income. And then this time we're going to do loan amount term. So loan amount term, that's what the column name is if you refer to the data frame. And then the kind to be KDE, right? So here we can see the same thing, the two densities for the two numerical columns and overall where their observations lie. So that's the joint plots that allow us to view the joint density distributions. But I just want to show you, individual KDE plots by themselves. You don't always have to use a joint plot. Sometimes if you just want to visualize a numerical column by itself, you can do that with the SNS.kde plot. So arguments, you might see there's a pattern here. Specify your data first. In this case, since you're viewing the distribution of one column, right, we're going to do one numerical column. So you just have to specify X, and then your hue if you want to do against a categorical column. And then this shade argument is, if you set it to true, that actually shades the area under the curve. I like to do that just so it makes the visualization pop out a little bit. So let's plot a KDE plot of the distribution of applicant income and make sure it is shaded. So plt.figure, fig size is equal to 12.6. And then plot the KDE plot, SNS.KDE plot, data is equal to df, x is equal to applicant income. And then let's set the shade argument to true. And then let's see. So here we can see that density here, and we get the KDE plot. So why I like to use the KDE plot is because histograms sometimes don't show like a smooth curve or like the overall shape. Like, if it's a normal distribution, it's easy to see from histogram, but when stuff is skewed, it's sometimes hard to interpret, or if there's a lot of like hills in the data. I like to use a KDE plot just see that smoothness. So that's that. And then let's do one more or a couple more here, but we're going to categorize by the distribution of property area. So we're going to use that hue argument again. So let's do plt.figure. Let's do fig size is equal to 12.6. And then let's plot the applicant income. Again, that distribution and categorized by property area. So let's do sns.kde plot. Data is equal to df, x is equal to applicant income. And shade is, and then hue, right? We said hue by property area. So property area. And then shade is equal to true. And then let's set the plot title. So let's do plt.title. Let's do distribution applicant income. So now here we can see kind of like these overlapping distributions for each property area, right? So we can see our overall distribution for applicant income, but how it varies across urban property areas, rural, semi-suburban, and just kind of visualize that a little bit. So this is helpful when we want to see how our observations differ across various categorical variables, right? So let's do one more. Let's plot Kde Plot the distribution of loan amount, but by categorizing by marital status and shaded. So plt.figure. Let's do fig size is, let's just do 10.5 for once. And let's do sns.kde plot. Kde plot. Data is equal to df, x is equal to loan amount this time. And hue is going to be married because that's the marital status. And then shade is equal to true. And if you ever, want to do a quick column check, right? By this point, I've kind of like memorized what they are because I've worked with this data set quite a bit. But if you want to ever just, check your columns real quick, remember, you can just do df.columns, right? And it will show you what the columns in your data set are. So that's how I'm getting these columns. So yeah, and then let's plot this. So we can see the loan amount, how it varies amongst the various marital status, right? So we, obviously your loan amount is going to be a lot higher if you're married because, you probably buy a house, stuff like that. So yeah, that's visualizing it with Kde plots and curves. So let's look at one more. This is the last one. It's called a Violin Plot. So a Violin Plot, essentially, when we see the shape of it, it's going to look a lot like a box and whisker plot, and that's the purpose of it, right? It's looking at the distribution of your data set. So it has that like violin like shape, but really it's just the distributions, like kind of like those Kde plots, but just on one line. And so the reason we like to use this rather than just box plots is because box plots only summarize the distribution with summary statistics, right? It only shows you your minimum, your median, your maximum, and like your simple summary statistics, right? But your violin plots are going to show you the overall distribution of all of your observations, right? So that's why I like to use this. So to do that is you just call sns.violinplot, you pass in your data frame, you pass in your X and Y. So you're going to pass in the categorical column you want to compare it against. So that's, like your gender or married status in this case. And then Y would be that numerical column you want to see the violin or the distribution of. And then hue, again, if you want to compare against categorical column. So let's plot a violin plot, the distribution of loan amount across different genders. So we're going to be plotting the distribution of the loan amount on our Y across the gender category. So that's going to be our x-axis. So let's do plt.figure. Fig size is equal to 12.6. And then let's plot the distribution, sns. Violin plot. Data is equal to df, x is equal to loan amount, gender, because we want to compare it against the gender. And then distribution will be against the loan amount. And let's plot that. So see, this is why it has that like violet. It's called a violin plot because it has that violin like shape. But really, this is just the distribution of the loan amount across the male and the distribution of the loan amount across females. So in this case, the distribution for males is the spread is a lot larger than females. So that's Violin Plots. So you can see it kind of has that box and whisker plot type of shape to it. So let's plot Violin Plot, the distribution of the loan amount across education levels. So our X is going to be education, right? So plt.figure, fig size, 12.6. And then let's do sns.violin plot for data is equal to df, x is equal to education. And then y is our loan amount. And let's go ahead and plot that. So when we do that, we're going to see the distribution of the loan amount versus the graduate and not graduate. So you can see this is less spread out because, again, if you have graduated with a degree, you've paid student loans or whatnot. So that's why the spread of the graduate is larger. So we'd expect that. And then let's plot the distribution of loan amount across gender, but this time we're going to categorize by marital status. So we're going to be making use of that hue argument here. So let's set the plot figure. So plt.figure, fig size is equal to 12.6. And then let's do sns.violin plot, data is equal to df, x is equal to gender, y is equal to the loan amount, and then hue, in this case, will be married. So the marital status. And so now we can see 4 violin plots because we see 2 violin plots for each gender because we're specifying that other categorical variable we want to compare against, which is the marital status. So we can see the spread of loan amount versus male and females, but whether, if they're married or not married. So it's interesting to look at here. And then let's do one more. Let's plot the distribution of loan amount across the self-employed status categorized by gender. So let's set the figure size, p.figure, fig size, 12.6. And then sns.violin plot, data is equal to df, x is equal to the self-employed status. So self-employed is the column. So df.columns, let me just double check that. Should be self-employed. Yeah, so it has an underscore, so self-employed. And then y is equal to loan amount. And then hue being gender. And why not? Let's just add a title here. plt.title, employment status versus loan amount across gender, right? Something like that. And so now we can see here another violin plot and the distribution of the loan amount, but across whether they're employed or not and the gender. So very, very good plots. So, Seaborn has a lot of, as you can see, this is already way more than what Matplotlib offered us, right? So I definitely like using Seaborn to visualize and do data viz with Python in Python because of the various customization, and also the syntax is just easier to work with. We've done the same thing.
So when you were doing the scatter plot, you said you had to put a categorical variable in the hue.
Yeah.
Would there be a way to do like a gradient sort of? I don't know, like an R, I think you can do a continuous variable, and then it'll like start at white and get like darker shades of black or blue.
Yeah, so let me look at that. So if you can actually check the documentation. So if you do help, and then let's go sns.joint plot. So here we can see, okay, so you have your x, y, data kind, color. So single color specification. So let me know if you can see this here. I'm looking through. I think there's a way you can you can do the palette. You can adjust the color palette, but I've never ever experimented with using a continuous variable in that regard. Maybe it's semantic variable is mapped to different color of plot elements. You probably could.
Yeah, I'm sure there's a way. Like, I feel like that's a pretty basic feature, but
very, very common feature. So you probably can. I've never experimented with that. Let me just like see what happens when I do that here. Let's just do. So
taking a while to run.
Yeah. So yeah, you can.
There you go.
You can do lone amount term, and you can do it by color as well, by your continuous variable. That's it for the intermediate data visualization in Python. And in general for data visualization in Python for this semester. We went through the intro to data manipulation or data visualization in Python. Now this is intermediate, so you guys know Matplotlib and Seaborn. And the advanced data visualization series is something we're going to bring to you next semester. So join us next semester to learn more and take your data visualizations to the next level. We're going to be talking about how to take these data visualizations outside of just a collaboratory notebook, right, on a dashboard. So we're going to be talking about a data dashboarding. That's what our advanced data visualization is going to be, where you're going to learn stuff like RShiny, Tableau, Streamlit, things like that, and also some other Python data visualization libraries like Plotly, which allow you to do interactive and moving visualizations. So yeah, thanks for coming to tonight's workshop. Hope you guys learned a new package for data visualization, and will join us next semester for more data visualization. So as always, if you have any questions, feel free to message me on Slack. Otherwise, have a good night.